Today's daily Leetcode question is a medium problem number 2196. Create binary trees from descriptions. You are given a 2D integer array descriptions where descriptions I is equal to parent I, child I is left I, which indicates that parent I is the parent of child I in a binary tree of unique values. Furthermore, is left 1 if is left is equal to 1, then child I is the left child of parent 1, and if is left I is equal to 0, then child I is the right child of parent I. Construct the binary tree described by descriptions and return its root. The test cases will be generated such that the binary tree is valid. So for example here, okay, I don't think we really even need to go through the examples. I think this is a pretty straightforward problem. So what we can do is we can first create we initially start by creating an array with every tree node, and then we go through the descriptions and connect the tree nodes. And then we have to know what the root is, and the root is just whatever node doesn't have a parent. And the way we can keep track of that is we have another array, or we could do like a set or something. I mean, I don't think that really matters that much, but yeah, I guess we can do like a set of every node initially, and then just use that to find out what's the parent. Okay. Actually, okay, annoyingly, I'm looking at the problem again. I just realized the nodes aren't numbered. And they don't have like a real index. So we're gonna have to create like a mapping to an index. Or actually no, we don't need a mapping to an index. We can just have, instead of having an array to store all the tree nodes in the beginning, we just use like a dictionary. And then we map the value to the dictionary. All right. So let's just do that real quick. We can do nodes is equal to that. No, dictionaries like this. Okay. Nodes is equal to that. And then root is also equal to that. Or it's a set, so like that. So now we can just go through the list for B in descriptions. Okay, the first step is just to initialize everything. That's the first pass. So we can just do nodes. Okay, yeah. We can do nodes D0 is equal to tree node with a value of D0, and then nodes D1 is equal to tree node D1. Okay, and even though we have like repeat initializations, it really doesn't matter, because we just want to make sure to union every single node that's like referenced here. And that wouldn't make the code that much slower because it's still linear time. So we can do that. And then we can also do root.add D0, root.add D1. And I think, yeah, that's it for the initialization. We can do for D in descriptions again. And then we can do just to make things clear, we can do a parent and child is equal to. Okay, so the parent is the first one. We can do nodes D0, D1. Honestly, we don't even need this. We can just directly go like if D2, so D2 is 1 when it is left, the left child. We can just do nodes D0 dot left is equal to nodes D1 else nodes D0 dot right is equal to nodes D1. And then, so we know if it's a child, then that's definitely not a root node, right? So we can just do root dot discard. This lets us not run into problems if we discard a node that's already been discarded. So we can do root dot discard. All right, root dot discard. Okay, I'm just thinking about how I would return the last element in the set, but let's just do this first. We can do root dot discard the child, which is going to be nodes, or no, it's just going to be D1. And yeah, I think that should be it, honestly. Return root dot. I don't even know how to just get like a random element out of a set. Can I do like root dot pop? I don't know. I don't think so. I only know how to like iterate over a set. Let me think. Okay, so there's no way you can just do like set 0, right? This might be a stupid solution, but okay, maybe it's just I can just do pop. So pop nodes that. Let's just try it. Yeah, oopsies. Oh, okay, pop. I can do pop with a set. Did not know that. But yeah, honestly, this is pretty straightforward, so I don't think I need any additional test cases. I can probably just submit it. Judging. Oh no. I'm a low efficiency demon. Oh, is there a better way to keep track of? Oh no, they use the same thing. Let's see. Oh, you know what? It's because they decide to do it in one pass, which you can do. I don't know. I just thought a 2-pass solution would be easier to understand, or it was easier to write. It's just more simple in the logic. Oh, my solution isn't too bad, but I definitely could have made it a one-pass solution. To make it one pass, I would first just see if like the nodes are already in it. If they're not in it, I'll put them in the dictionary. And then if they are in it, then that's great. We can just use them directly. And then I run like this code. So maybe not too, what's it called? Maybe not too complicated, but I don't know. I still think this is simpler. All right. Well, that's problem 2196. And thanks for watching. Bye bye.